Hey everyone, in this video, let's take a look at question 20, valid parentheses on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, we are given a string as containing just the characters, which is basically the list of brackets that we can use, and we want to determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of closed brackets. So basically, open bracket of this type must be closed by same type. Open brackets must be closed in the correct order, so we can't basically have something like this. We also can't have something, let's say, something like this and then this. Well, we can't have something like this because it's not valid here. And similarly, every closed bracket has a corresponding open bracket of the same type. So we can't just have a closed bracket. Like there has to be an opening bracket somewhere before this that actually closes us out. Okay, so how might we go about doing this? Well, let's make a few observations here, right? When we are creating our brackets, I'll just create some random brackets here. Okay, so what do we notice? Well, if we are creating our bracket, then we have two choices, right? We can either close the bracket or we can just continue to open the bracket. Now notice, if we open the bracket, right? If we open the bracket, we expect to close it later on. If we close the bracket, then we expect there to be an open bracket of the same type before. Okay, so that's helpful. So for example, here you can see I just continue to open these brackets and then I go ahead and I close the bracket here. Okay, so now that I close this bracket here, we can see that this closed bracket here applies to this open bracket here. So this is done. But now notice that for this bracket here, it's not like I can just look before, right? It's not like I can just look at the element before because this element before is actually a closing bracket. I actually want to look at to see like what this might match. What this might match here is actually this thing over here, right? So if this is already done, then basically I can just ignore this. And then this thing, I have to somehow see if there's an open bracket that happened in the past that I can match, right? So how can I go about doing this? Well, a data structure that might kind of be useful here is a stack, if you think about it. So let's see how we might be able to use a stack. If we had a stack, then what do we want to put in our stack? Well, let's see. If we had just the open bracket, then we can maybe just put this on the stack. And then every time we see a closed bracket, we would just check the last type of bracket we saw on the stack is essentially the same type as a closing bracket we receive. What does this mean? So let's say in this example here, we'll add in the following to the stack. All of this we will add into the stack. All of this we will add into the stack. Now, if we see a closing bracket, then what does it mean? Well, it means that in the past, I must have had a opening bracket of the same type somewhere. And I can record that information, I can record that memory in my stack. So if I have a closing bracket here, I would basically look to my stack. And where would I look on my stack? Well, I can't just look anywhere, right? I have to look at the top of the stack. I have to look at the most recent bracket that I've added on. So the most recent bracket is this one. So I can see here, there's actually a match here. I can go ahead and pop this off. And then so far, what I can understand is this much is valid. I don't know about the rest of it, but this much is at least valid. I'll go ahead and end this. Now I come across this. If I come across this square bracket here, then I want to look in my stack to see, did I have an open bracket in the past? Well, of course I did have an opening bracket, but not only that, I want to look at the top of my stack because the open bracket has to be the most recent bracket. We can't have something like maybe, let's say we had something, if it was something like this, and then maybe here we had something like this, right? We can't have something like this. Or actually, maybe let me do this and I will do this. Yeah. So this is not this is basically invalid because even though this is valid here, when I look for this, I'm expecting an open bracket of the same type. Now we can see we actually have an open bracket over here, but it's not the same, it's not the most recent one. After this, the most recent one was over here. So basically this bracket here, this closing bracket here, is matching with this bracket here. So that's why we need to store that information on the stack. So that's why we have a stack to store the most recent information. And because stack is last in, first out, we basically add in the last bracket that we added in onto the stack. And so we can always check the top of the stack to see if we can form that pair. And then similarly here, we can form all of these pairs. And so we have our answer. So let's take a look at how we can go about doing this in code. So we know we need a stack. All right. So first of all, what can we start off with? Well, we know that S can be empty, right? So if S is empty, you can just return false, or I guess true. Not actually, no, S can't be empty, so we don't have to worry about that case. So let's just initialize our stack here. We'll go through our string here. Now, what do I want to do in my stack? Well, I want to add in the open brackets, right? I want to add in the open brackets onto the stack. So how do I know something is an open bracket? Well, I could basically just check like if item in this open bracket here, maybe it's in something like this, maybe it's also in something like this. If this is the case, then I'll go ahead and add it to the stack. So I'll do stack.append item. Otherwise it's a closing bracket, right? And we actually are guaranteed that we only have opening and closing brackets, so we can't have anything else. Now it's a closing bracket, so basically what do I need to check? Well, now we need to check that whatever is on the stack, it must be an opening bracket of the type that I'm expecting. So for example here, if I receive something like this, if item is something like this, then on the stack, on the top of the stack, I would like to have this. I would like to have that the most recent bracket I added is this opening curly brace. So how can I do that? Well, first of all, I can check. So first of all, if not stack, if the stack is empty and I see a closing bracket, then obviously this is not correct, right? Because it's as if like I add something like this, but maybe this occurs half after. So we'd have a scenario like this. So this is false. Otherwise, what? Otherwise, we can go ahead and pop the item, right? So we can do top is equal to stack.pop. So in the case for something like this, let's say we had this and this. To the stack, we add in this opening bracket. And so we are done basically this. Now we are processing this. So now I go ahead and pop this off the stack, right? Now I pop this off the stack. Now I basically need to see that like these two are matching, right? So how can I do that? Well, if you think about it, I can just create like a lookup table, right? Like a hash map. I can map this to this. I can map the. So what I'm saying is I can basically create a hash map where I can map maybe this closing to this opening. Maybe I map this closing opening, and maybe I map this closing to this opening. So maybe I do something like this. So now what can happen? Well, now that I pop off the stack, I will pop this off the stack, and basically all I need to check is the value, like the what does this map to? This maps to this. So if that's the same, like in the hash map and whatever I pop off, then I know that I have a pair. So I can check if d at top, not d at top, d at item, because we are adding in like the back brackets, the closing brackets. If d at item is equal to top, then we're all good. But if it does not equal top, then it's another case where I want to return false. So I want to return false here. So in this case, it's something as if maybe my stack had this at the top, and here I'm popping off this. Well, this is not like the same type of bracket, right? So this does not work. Okay, so that's basically what we do. And we can actually kind of simplify this. Instead of checking here, we can just do if item not in D, right? Because you can see here, like D is like the list of closing brackets. So if it's none of these, then it has to be the opening brackets. So that's just an optimization we can make. Now, otherwise, what can we do? Well, we would expect we can return true, right? But not just yet, because if you think about it, like, what if we just have like all opening brackets, right? What if we just have all opening brackets? Then we would just keep adding on to this stack, but we would never like really pop anything off. And if you really think about this, the way this works is that if every opening bracket has a corresponding closing bracket, then we should pop them off, right? So in the end, the stack should be empty. So one thing we can actually do is not return true, but return not stack. So basically, if the stack is empty, we'll return true. If the stack has items, then we'll return false. That's basically all there is to this question. So let's take a look at the time and space, assuming we get the answer right. Okay, so we got the answer right. Perfect. So what is the time and space here? Well, time, we're just going through the list ones, right? The string ones. So that's O of n. And for the space as well, because we're adding it to the stack. So that's also O of n. Okay, thanks for watching.